All right, so let's move on to a while loop. We know that while loops can mimic a for loop very easily. So I'm going to create an int variable. I'll call it number. I'm going to initialize it to 10. We're going to see if we can get it to count down. So this time I'm going to say while number is greater than or equal to 0. Let's see if we can get it to count down with my opening and closing curly brace. So we'll put the end while comment on the closing curly brace. And then I am just going to see out num to see what's in it. And I am going to force a new line after that, just so that they're on separate lines. But then the one thing that we have to remember is to change that condition. Because we don't change that condition inside the parentheses of the for loop, we're going to have to change the condition ourselves. And the way that we're going to do that is we're going to decrement num. So before I run it, I'm going to capture. I'm just going to force a couple of new lines. I had done that on line 28. I guess another way that we could do that is we could just see out, and then inside of here I could put a text field that just has a couple of new line characters inside of a text field. Line 41 will have the exact same outcome as line 28, where we are forcing two new lines. All right, so let's run it and see what happens. All right, so what I see is it is counting down from 10 to 0, which is, we can mimic a for loop doing it. But of course, because I changed that condition inside of the while loop, it makes it so very much more flexible. I did want to mention that line 32, my int alpha, there are some dots underneath alpha, and they're there because the alpha hasn't been initialized to anything. If I hover my cursor over it, Visual Studio is going to tell me that the local variable has not been initialized. So I initialized it inside of here, but it wasn't initialized there, so it's just giving me kind of a warning. Anyway, I thought I'd bring that up. So let's continue on with our while loop. All right, so what we're going to do is we're just going to have them enter a number, and then when they're done entering numbers, we're going to have them enter a 0 to quit. So I'm going to use the same number, the same variable called number. This time I'm going to set it to 99. We'll just set it to some starting value or initial value that will let me into the loop. And this is going to say while num is not equal to 0. My opening and closing curly braces. And then inside of here, I am going to ask them to enter a number. So I'm going to see out and I'll say something like enter a number. Now I am going to give the sentinel value. I'm going to tell the user what my sentinel value is. So I'll say 0 to quit. Tell them what the sentinel value is so they know how to stop the loop. So we're going to prompt them for the number, and then I'm going to read that number in. I'll put it in CN, so we're going to capture the number. And then we are going to print out, see out, something like, and I'll mirror back, oops, is a nice number. Oh, did I miss my number? Oh, there we go. And then we will force a new line. I guess we could also, instead of typing in the end line, I could just force a new line inside of that text string. Since that's the last thing on my line, we can force it inside of the text string. So what's going to happen is my starting value for number is 99. My starting value for num is 99, which is a value that's going to allow me to drop into the loop because 99 is most definitely not equal to 0. It's going to prompt for a number capture. It's going to tell them it's a nice number, and then it's going to repeat the loop until such time as num equals 99. So let's run it and see what happens. Oh, it's asking me for a number, so I'll put in 15, I'll put in 20, I'll put in minus 200. But as soon as I put in my sentinel value 0 to quit, then the program will end. And that is the flexibility of a while loop. For loops count up, they count down. You can actually change the condition instead of incrementing plus plus by 1. You could increment by 15 or 25, or you can decrement by 19. So instead of saying count plus plus, I could just say count equals count plus 10, and that would increment by 10. The while loop, on the other hand, is much more flexible because I don't have to count up or down. I can do this an unknown number of times. It will continue, this loop on line 56 will continue to execute as many times as necessary until the user puts in my sentinel or my exit value, which is 0. All right, so let's do another one. So what we're going to do is we're going to raise a number to the 4th power. So we cubed a number. Is this called quad? Quad a number? I don't know. We're going to raise a number to the 4th power. So let me write a little bit of pseudocode for about what we're about to do next. So we're going to create a couple of variables. I'm pretty sure that we already have a number. So we need a number that we're going to raise to the 4th power. I probably need some kind of variable to put in the answer. And then what we're going to do is we're going to tell the user what's happening, so they just know what we're about to do. And then I'll say while answer is less than 5 digits long. I'll tab in because this will be a part of my while loop. We're going to display the number, and we're going to do it 3 wide. So I'll set the width there, 3 wide. And then we will display the answer, and we'll do the answer 6 wide. So we'll put it in a field that's 6 wide long because the answer is going to grow very, very fast. And then we are going to increment to the next number. And then once we have done that, we're going to calculate the 4th power. Did we say that was quad? 4th power, if we can. The cube is 3, then quad has got to be 4, right? Okay, anyway. So there we go. This is what we're going to do. Let's go back in and fill a little bit of detail. We already have a number, so I'm going to reset number to 1. I know that we've been using number before. I'm going to reset number to 1, and I'm going to start answer as a 1. So because 1 raised to the power of 4 is just 1, right? And so I'm going to create a variable. We'll make this an int variable, and we'll just start it off to 1. So tell the user what's happening. Fine, we'll come up here and we'll see out something like fourths from 1 to, and I don't know how far up we're going to go because while the answer is 5 digits or less, we're going to stop when the answer grows past 5 digits. So I'm not exactly sure. We'll force a new line inside of there. Not exactly sure how far we'll get. And then while the answer is less than 5 digits long, so I'm going to put a while. And I'll have my opening brace. Now, because I already have some comments, I'm going to have to delete that closing brace, and then we'll put it back down in here so that I can say end while. And then the condition on the while is going to say while answer is less than, I wanted it to be 5 digits long, right? So 5 digits long, that would be 1, 2, 3, 4, 5, 6. Do I have too many zeros? 5 digits or less. 1, 2, 3, 4, 5, 6. There you go. So the first thing that we're going to do is display number. So we're going to see out, and then I'm going to set the width to 3. And then we will say number. And then we're going to do the same thing with the answer. This time we're going to set width to 6 for answer. I am going to add one little bit more thing to the number. So I'm going to say like 1 raised to the power of 4 is, 2 raised to the power of 4 is. So this number, and then I'm going to add a text field in here that says raised, that's the symbol, raised to the power of 4 is, and then I'm not going to force a new line because I would like my answer to display on the same line. So ultimately what I'm trying to say is 1 raised to the power of 4 is, and the answer would be 4, right? So I want it to be on the same line. So then we're going to increment the number. So this is going to be plus plus now. So I'm going to pre-increment the number. So I'm going to increment it before we use it. This is the pre-increment, and then we're going to calculate answer equals, and I'm going to use the power function. So I'm going to raise there are two parameters to the power function. The first parameter is the power that I want, the base, and the second one is the exponent. So I'm going to raise number to the power of 4. So one more thing that I'm going to do to this is we want to force an enter key, so each one of those calculations is on a new line. So I'm going to come down where we are displaying the answer, and we will just do an end line here so that we can force a new line. Oops, I have too many less than symbols. There we go. All right, now this power function, you may or may not have to import depending upon the platform or the IDE that you're using. You may or may not have to import that library that the power function is in. And so if I scroll back up here to the top, you may have to pound include, and this is the math.h, and this would be for the power function. Now, depending upon the IDE that you are using, you might have to include, oops, I got to spell it right, math.h. All right, so let's run it and see what we get. All right, so this is our prior one, that the sentinel value is 0 to quit, and as soon as we do that, it says 1 to the 4th is 1. That's where we started with our initializations, and then it's going to march down up until we have 5 characters, or up to 5, and once we have exceeded 5, it's going to stop at 17 raised to the 4. So let's see if we can do a slightly longer number. What would happen if instead of putting 5 digits in there, what if I put a few more digits in there? So I'm just going to arbitrarily put 4 or 5 more zeros at the end of my number inside of line 73. This line right here, I'm going to make my answer much, much larger. And let's run it again and see what happened. All right. So I'll put a 0 in here, and then let's see what happens if my answer is a whole lot larger. If you'll notice, the answer, I'm now trapped in an infinite loop because my answer now appears to be a very, very large negative number. Why do you think that happened? Yes, you're right. If you said you thought it probably happened because answer is an int variable, and I have just expanded or exceeded the capacity of an integer variable, you are absolutely right. So let's do this one more time, taking into consideration that something raised to the power of 4 can become a very large number very, very fast. So let's do this again using different data types that might allow us to get a much larger number. All right, so then we're going to do this again, but we're going to allow answer to be a much, much longer number. So I'm going to make this unsigned, and we'll make it a long, and I'm going to call the variable, how about if we call it long answer? Spell that right. Long answer. We're going to initialize it to 1, and I'm going to put U for unsigned. So we're going to initialize it to a long, and it's going to be unsigned. Hopefully by now you're familiar with the difference between signed, the capacity of a signed number and an unsigned number. So I'm going to repeat the same while loop that we had before. So this is going to be while long answer is less than, and then 1, 2, 3, 4, 5. Those were the original 5, that it was less than 1, 2, 3, 4, 5, 6. I'll have my while loop inside of here. And we're going to do the same things inside of here. If you don't mind, just for the sake of time, I'm actually going to steal everything that was inside of my original while loop. I'm just going to copy it. I'm going to paste it down inside of here. I will have to make a couple of changes. First of all, we're still using the same number. We're going to still raise it to a power of 4. I'm going to keep that to be 3 characters wide. But this time, instead of answer, we're going to use long answer. And, oh, that should be a lowercase l. And instead of 6 characters wide or 6 spaces wide, I'm going to make it 25 spaces wide. So I'm going to increase the size of that. We're still going to increment it before it's being used, because right now I had set it to 0 when we first came in. Excuse me, when I first came in, it was set to 1. So then I displayed it here as the 1, and then I want to pre-increment it to 2 before I raise it to the power, because we kind of hard-coded the first one, right? We hard-coded the first one. And so I want to pre-increment it before then I raise it. I'm going to increment it to 2 and then raise it to a power of 4. So the only differences that I made here is that I increased my value of long, or I changed my answer to a long, an unsigned long, and then I increased the size of the space to 25, and then we are going to run it and see what happens. So I'll just set a 0 here. Can anybody tell me what my problem was? It was in an infinite loop and the answer was always 1. That's probably because this needs to be long answer. All right, let's try it one more time. See if we're actually getting a correct value this time. All right, we'll run it, put a 0 in here and see what happens. Well, I can see the first run of my program right here. This is when we're using an enter. And I see this is the beginning of the second while loop. I can tell that because this 1 is way out at a 25 width field as opposed to the original 6 width field. But can you tell me what happened? I'm going to stop the program and can anybody tell me the logic error that I made within my program, because it's definitely not doing what I'm expecting it to do. So I think that the hint of what this logic error is in the fact that this says 18 raised to the power of 4, and immediately it was 17 raised to the power of 4. So the main problem is that I never reset number. So I'm going to have to come back up here, and because number from the while loop immediately above it went all the way to 17. And when I dropped out of that loop, because number is not within the scope of the while loop itself, but in the scope of the entire program, that number is still 17. And so if I want my program to run again, I'm going to have to reinitialize or reset number to 0. And this should then start it over again. So now we're going to run it and see if we get what we expect. So I'll put the 0 in here. There we go. Now I have the 2 runs. And if you'll notice, they both went to 17, right? But if I took the first while loop and the int answer and I went out to a much larger number, it exceeded the capacity or blew up my integer variable. Let's see if we can take this second the long answer, the second one, 1, 2, 3, 4, 5, 6. I'm just going to add a bunch more zeros to it, and I'm going to run it one more time. Let's see the 2 runs of those while loops. Holy moly. It looks like this one went all the way to 564. So it looks like we did not exceed the capacity. So this one stopped at 17 raised to the power of 4. And I don't know the number before we would have blown up that int capacity. But it looks like we started back at 0 to the 4 is, actually that should be 0. But with our long answer, we were able to go all the way up to an exceedingly large number. And I'm assuming that we could continue increasing the size of that condition to get an even larger number.